I suppose that I have chemical process engineers following up my content and this class, and what we have here is a pump that is responsible to transfer a liquid fluid from the sheet C01, and it comes from the vessel 660, and you can see that I have an indication of insulation here. I'm not so sure if it is insulation for hot stream or if it is an insulation for cold stream, but for us doesn't matter right now. And we have the size of the pipeline at the suction of the pump, and we know that because we have the tag or the numbering of the line here, and in this case we have the nominal pipe size, we have the fluid code, we have the kind of material, and we have the sequential number. And after that we have an isolation valve, a strainer with a drain valve, and a reducer in order to get the pipe of 6 inches, and we select this pipe size based on the pressure drop from the vessel to the pump suction, and also using criteria of velocity. And we have a drain valve here in order to be able to do the maintenance of the pump in this case. And there is a manometer at the inlet of the pump and another manometer at the outlet, and it could be a differential pressure indication. It would be the same because it is important to regulate the head of the pump, and with that we regulate the flow through the pump. And at the discharge of the pump we have another reducer, and observe that although we are in fact we are not reducing, but we are getting from the smaller to the higher pipe size. The name of this fitting is reducer, so we always will draw this, or will write this as from the higher size to the lower size. And we have check valve, isolation valve, and another reducer. And we go to a filter, and it is a sieve filter, and the fluid goes outlet from the filter, go to a heat exchanger, and this type of heat exchanger is a plate type, and the fluid goes this way, and the outlet is this way. So we have this path here, and finally it goes to the battery limit of this sheet, where we have a flow valve, a flow control valve with a flow meter that sends the signal to a control fluid indication control that is responsible for sending the signal to the flow valve in order to open more or closes more the valve to control the flow. And to guarantee the heating exchanging, we have a cooling water supply and a cooling water return. So we can imagine here, based on the fluids that we have here, that is a process of cooling down the fluid and not of heating up, because if we have cooling water supply, if it's cooling, that it means that its service is for cooling, not for hot. In the other hand, if we had hot water supply, it would be for heating up, not for cooling. And to verify if the heat exchanger is not dirty, or if the performance of the heat exchanger is good, we have a DPI, that is a differential pressure indication, and that we are using a plate, and it is very sensitive to dirt, and if we have dirt we will have less area of heat exchanger, and we can evaluate based on the pressure differential if we need to clean up or not the equipment. Besides that, we have a local temperature indicator, so you can see this only in the field, and it is this way because we have only a circle on that, and we have a transmitter with a signal to alarm of high temperature, because we have a TAH, so it is a temperature alarm high. And we have here a pressure indicator transmitter, so in the field we have a pressure indicator, but this pressure indicator also sends a signal to the PLC in order that the control room are able, the operators are able to see in the control room the pressure indication of this stream at this point. So besides that, we have some safety valves here. We have a PSV at this point, and we have a PSV at this point to protect the system. And this is the overview of our process. And finally, we have a stamp here, and every time that you draw an engineering document, you need to have a stamp to identify who did that, who approved it, who revised that, and etc.